Okay, we're going to work on graphing quadratic functions. Remember, quadratic functions have a U-shaped form. They could be wider or very, very narrow, but they're a U-shaped form and they're continuous. They don't have any breaks in the graph. And an easy way, or maybe an effective way to graph a quadratic is to find the vertex. Remember, the vertex is either the lowest point of a positive quadratic or it's the highest point of a negative quadratic. And to find the vertex, you take the opposite of the b value and divide it by 2 times the a value. So there's that invisible a is 1, positive 8 is b, 13 is c. There's a quadratic in standard form. And then the vertex is the opposite of b. So the opposite of 8 is negative 8. And then 2 times 1 is 2. Negative 8 divided by 2 is negative 4. And then you take the negative 4, since we know what y is equal, you just plug this x value into the quadratic. All right, so we're going to plug negative 4, so y is equal to negative 4 squared plus 8 times negative 4 plus 13. So negative 4 is squared is 16. 8 times negative 4 is negative 32. 16 plus negative 32 is negative 16. Negative 16 plus 13 is negative 3. Okay, I'm going to erase all this stuff. You can just pause it if you need to write that down. So now we know the vertex of the equation. So at negative 4, negative 3, negative 4, negative 3, we're going to draw the vertex. All right, then since the x value is negative 4, you can choose two x values to the left, negative 6, negative 5, and then 2 values to the right, negative 3, negative 2. Here's the cool thing about parabolas. They are symmetrical about the vertex. So once you know the vertex, if you choose a point here, its height, the same distance over here will be that height. So what that means, because that might sound a little confusing, when you plug in negative 6 is 2 away from negative 4, 1, 2, and negative 2 is 2 away from negative 4. So those two heights should be the same, and then negative 5 and negative 3 should have the same height values. So because it's symmetrical, you really only have to plug in 2 of these x values, and then when you plug in negative 2 into this equation, that answer, let me do this, will be the same for that. So we can say y is equal to negative 2 squared plus 8 times negative 2 plus 13. Negative 2 squared is 4. 8 times negative 2 is negative 16. 4 subtract 16 is negative 12. Plus 13 is 1. So since that's 1, this should also be 1. Okay, so at negative 2, I'm going to put a point at 1. And at negative 6, I'm going to put a point up here at 1. All right, so we have that figured out. Now we'll put in negative 3. Well, negative 3 squared is 9. 8 times negative 3 is negative 24. 9 subtract 24 is negative 16. Whoops, negative 15, excuse me. Oh, did I just... Plus 13 is negative 2. So at negative 3, we put a solid dot. At negative 2, and at -5. The other key piece of information that I want you to understand is parabolas are symmetrical about this axis of symmetry that runs through the vertex. So whatever that x value of the vertex, there's a vertical line that runs through that. So all you have to do, if it's asking about the axis of symmetry, just look right here, the x value of the vertex, the axis of symmetry, x is equal and to the x value of the vertex, and that is the equation of that line right there. Okay, we're going to do one more real quick. Oh, this is getting to be a long video, but now it's in vertex form. We can look at this and know the vertex right away. So for the x value, what's the opposite of +2? -2. And because on the outside we do exactly as it says, we just -2 up 1. That will be the vertex. I'm going to put a capital V there to indicate vertex. And then I'm going to choose 2 x values to the left, 2 x values to the right. And I'm going to plug in 0. 0 plus 2 is 2. 2 squared is 4. 4 plus 1 is 5. And remember, these two will be the same. So at -4, we go up to 5. And at 0, we go up to 5. And then I'm going to put -1 in there. -1 plus 2 is 1. 1 squared is 1. 1 plus 1 is 2. So at -1, we're up at 2. And at -3, we're up at 2. And remember what I said about the axis of symmetry. It runs through the vertex. It's a vertical line through the vertex. If it were a sideways facing parabola, it would be a horizontal line. But for an upward facing parabola, the axis of symmetry is a vertical line. And so axis of symmetry, I'm going to abbreviate it, is where x is equal to the x value of the vertex. All right, that's it for graphing quadratics.